Your friendly neighborhood Algebra 2 teacher back at you with another example. So here's another equation of a polynomial function, and it's asking us the same questions as what we were asked in example 1. So we're going to go through them together and make a first sketch or a first draft, and then also make a second draft for our graph. Okay, so let's go ahead. So what are all of the zeros of our function g of x? So for that, we're going to look right up here, and we want to use our zero product property to figure out what all of the zeros are. So we're going to set x plus 7 equal to 0, subtract 7 on both sides, and one of my zeros is at -7. Another one of my zeros is going to be at x equals 3. I'm not going to show all of the work for that. You might not need to either. I'm just going to save us some time here. I've got another 0 at x equals -2, and our last 0 is at x equals 1. So I'm going to go ahead and just place those somewhere on my graph so that I've got a working sketch. So here's x equals 1. I've got another one at 3. I've got one at x equals -2, and I've got another one at x equals -7. So I'm going to put those points on my sketch. Okay. All right. The next question is, what is the degree of the polynomial? Now remember, to figure that out, I would need to multiply all of these terms out. But to figure out the degree, all I really need to do is multiply the first terms of all of these. So x times x times x times x. And the first term, or the first term of this polynomial equation would have the degree of 4, because I end up with x to the 4th. And actually, when I multiply it by this negative in front, the leading term coefficient is going to be -1. So if you were to multiply all of that out and write it in standard form, the first term in your standard form would be this right here. Okay, so now that we know that, we can get our degree. The degree is the highest exponent, which is 4. The leading coefficient is -1. Okay, the next thing they want us to do is figure out the y-intercept. Now remember, to figure out the y-intercept, we need to plug in 0 in for x. So I'm going to plug in 0 for every x I see in this equation. And I end up with 7 times -3 times 2 times -1. So I end up with -42. So that -42 is going to come down here. I'm also going to write it right here for clarity's sake. Okay, so now we're going to use the above information just to make a quick sketch. Alrighty, so since I know that my degree is going to be even, my polynomial is going to look something either like this or like this, where the ends of my graph are going in the same direction, and that only happens when the graph is even. Since the leading coefficient in the front is negative, both of the ends of my graph are going to be pointing down. So you might have a graph that looks like this. Here's our first sketch of that graph. Now, remember, once we've got a sketch, we want to be able to just type it into our graphing calculator or type it into Desmos so that I can get a better second draft, I should say. So I have negative, and then x plus 7, x minus 3, x plus 2. I think the last one was x minus 1. Here we go. Alrighty, let's edit this window. I want the y's to go as far down to, let's say, negative 150, and the top all the way up to positive 150. Okay, so it goes even higher than that. So let's make this a little bigger. Let's make this to negative 200, and let's make this to positive 250 because it looks like it goes higher up on the left side there. Okay, still don't see the whole graph. Okay, here we go. Alrighty, so my graph looks like, or this is what your graph should look like. Mine does not look like that. So we're going to make some edits just really quick. So let's see, right here, and it comes all the way up here and then down here. And then our second draft is going to come back up after our y-intercept and then back down. Okay, so here's our second draft of our polynomial function, and that looks a little closer to what the Desmos, our sketch now looks a little closer to what was on our Desmos graphing calculator. All right, thanks for watching. Let's go ahead and do some more examples, but in different contexts, like looking at equations in table, or writing an equation from a table, or writing an equation given a graph. So going in the other direction than what we're doing now.